Okay, section 2.6 is called related rates. We're going to need lots and lots of formulas that we used in geometry in order to do all of the word problems for related rates. We're going to hold off on actually doing those word problems, so the 2.6a and 2.6b videos and assignments, we're going to wait until a future unit, future test to do those two things. But related rates, those formulas work so well with section 2.5, so this is going to be our 2.5b video. We're going to be taking derivatives with respect to time. So instead of d dx, it's going to look like d dt. Every single variable that we take a derivative of that is not a t, we are going to have d and then whatever that letter is, dt. Let's take a look at circles. We have two formulas for circles that we've used pretty often back in geometry. So we've got a equals pi r squared. That's the area of a circle formula. We're going to take the derivative of that with respect to time. What that means is that the radius and the area are both changing as time goes on. Okay. This often shows up in problems where there's like a ripple, like you drop a stone into some water and then there's circles that emanate out from the center. So this would be change in area and a change in radius would be happening at the same time. All right, so let's take the derivative of both sides with respect to time. The derivative of area is going to be dA dt, and that's going to equal, r is our variable, pi is just a number, so think about pi as like a 3.14-ish type thing. We're going to take the 2 exponent and multiply it times pi, so that's going to be 2 pi. We will still have an r, but since we're not taking the derivative with respect to r, it's with respect to t, you're going to put times dr dt. And that's it. That's what you do. That's how you take the derivative of a formula. Okay. So it's possible that you will still have some of the original letters, like we had an r still. It had an exponent of 2, so we still have an r. But a, we did not have an exponent, other than invisible 1 on the a, so we just end up with a dA dt. C equals 2 pi r, so that's the area for circumference of a circle. Take the derivative with respect to time. The derivative of c with respect to time, derivative of c with respect to time will equal, when we take the derivative of a coefficient multiplied times r, all that we're going to be left with is that coefficient. So that's 2 pi. But we use the chain rule, which says that anytime we have a letter, which is not what we're taking the derivative with respect to, we are still stuck with that letter kind of like this. So it'll be dr dt. Now you might be thinking, why can't I just use r prime and c prime? Those primes kind of represent that we're taking the derivative with respect to x. So the fact that time is changing, we should really be putting the dt's down there on the bottom. Okay. In fact, AP, when they grade at the end of the year during the AP exam, if you just put c prime and r prime, they will not give you full credit. You have to use dc dt and dr dt. Okay. We're going to do a couple more of these together, and then the rest of this page is going to be your assignment, except for the very bottom 2. So I'm going to cross a couple of these off. Right circular cones, that's just a cone, like an ice cream cone, like a traffic cone, whatever. You are never going to use these formulas, ever. So just cross those 2 off. Any of the rest of these, it is absolutely possible that you could end up being asked about one of these formulas on a test or on the AP exam, on the Johnson County College Now exam. All right, so let's do rectangular prisms. We have volume equals length times width times height. We have 4 different variables. That means we're going to have 4 different pieces to this. On the right-hand side, you might notice that we have a product. We are going to have to use the product rule. There's no product rule that has just like 3 letters, like when we do U and V and U prime and V prime, there's no product rule for 3 different factors. So unfortunately, we have to do the product rule once with like L times WH, and then we have to do it again when we take the derivative of the WH portion. So it's a little bit tricky. Okay, let's start by taking the derivative of V. We're taking the derivative with respect to time, so that will be dV dt equals. Okay, now off to the side, let's do those U's and V's. I'm going to put them just below on my scrap paper. So U is going to equal, let's do L for U. And then for V, let's do W times H. Now, this V is not that V. This is just like our normal side work stuff. Okay. U prime is the derivative of L, and we're taking that derivative with respect to time, so dL dt. I'm doing a weird curvy L so that it doesn't look like a 1. Okay, and then V prime will equal the derivative of W times H. So V needs a product rule when we find V prime. Okay, so normally it's like U prime V plus UV prime. So let's take the derivative of W. That'll be dW dt. And then we keep the second one, so times H. Plus, then we'll keep the W and multiply that times the derivative of H with respect to T, dH dt. And I'm going to stick all of that in a big bracket for V prime. Alrighty, so we'll have U prime V plus UV prime. U prime V, let's put the W and the H first, and then we'll put the dL dt last. So W times H times dL dt plus, then multiply U times V prime, so L times, and then that bracket. Bracket was dW dt times H plus W times dH dt. Whoops, H dt. All right, there is no extra simplification that you need to do on that. What the problem would give you, the word problem, they would tell you all of these pieces of information besides one. So they might ask you for the change in volume, but then they would have to tell you the width, the height, the length, and how fast the length, the width, and the height are all changing. They would have to give you all 6 of those pieces of information just to find this one. Okay. All righty, we got one more here. It is surface area. It looks like we're going to have to do 3 different product rules, one with 2L and W, one with 2L and H, one with 2W and H. Okay. On the left, SA is surface area. That is one variable, so it's going to be dSA dt. Okay, maybe we can do the product rule on this one without writing out the U's and the V's. Hopefully we can do that. Let's try it. Okay, product rule for this first one. I'll do blue for this first one, and then I'll switch colors for each separate term. So 2L times W. The derivative of 2L is going to be 2 times dL dt times, and then we keep the W, plus 2L is our first function, times, and then the derivative of W, dw dt. Okay. Second term, 2LH. It will be the exact same stuff, except everywhere there was a W, there's now going to be an H, right? Because all the L's were the same and the 2's were the same. Okay, so it's plus 2 dl dt times H plus 2L times dH dt. Okay. Third letter combination, we have W and H. So if I take my green and change it to orange, if I take green and I just separate out the L's and replace them with W's, separate that L, replace it with a W, then the H's can stay the same. Okay, so plus 2 dw dt times H plus 2W times dH dt. Yay! It's a lot going on that one, but it's the same thing 3 times, just different letter combinations. All right. Are there any others on here that we really want to do together? So I'm asking the class that's in the room at the moment. You can probably do 1 or 2 more together, and then I'll stop the video. All right, can do. Surface area of a cylinder. So we've got 2 pi r h plus 2 pi r squared. Derivative of surface area, what's that going to be? Good. dSA over dt equals. What kind of rule do we need for 2 pi rh? Product, awesome. So 2 pi r is going to be our first function, h will be the second function. Derivative of 2 pi r is going to be 2 pi times, and then instead of r, what will we write? Good, dr dt. And then times that second function, which is just an h. Okay, second half of the product rule, h is the thing that we're going to take the derivative of this time around. So plus 2 pi r times, and then the derivative of h is? Awesome, dh dt. Okay, green for the third. This is not product rule. It's going to be a power rule because r is squared and there's no extra letter. So 2 pi r squared. Power rule. What are we going to do with that exponent? Good. Multiply it times that 2. So 4 pi r, because the exponent decreases by 1, we are still going to have the r that was already there with an invisible 1 exponent. But r is a function, so we're also going to have the dr dt at the end. Woo! All right, is there another one you want to see, or do you guys want to try these on your own? Okay, that one looks way more complicated than it is. It's a product rule. Is there a different way that we could rewrite this one? You could do that. 3 is a constant, right? Could we make that 3 part of the coefficient? Yeah, exactly. We could put pi times 1/3, or we could put 1/3 times pi, or you could put pi over 3, any way that you want to do that. And then it's a product rule. You want to see that one anyway? Or is it good? Sure, okay. Let's do it. Okay, left side, derivative of volume, dv dt equals, let's have this be our first function, pi over 3 times r squared. So we'll take the 2 and multiply it times pi over 3. That sounds like 2 pi over 3 to me, times r, to the invisible 1 exponent now, times, we're taking the derivative of something that was not a t, so dr dt. And then we'll go ahead and put that h next to it, so times h. Plus, then we keep the original function, so that's going to be pi over 3 times r squared. And then times the derivative of the h function, which is just dh dt. And there it is. All right, that sounds pretty good for the video. The rest of these, besides those bottom 2 cone problems, are going to be your assignments that gets turned in for 2.5b.